Unit 1, Lesson 4, N4. The distributive property. Evaluate expressions. The distributive property states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. So as we can see in this example right here, A times B plus C is the same as AB plus AC. Similarly, with subtraction, A times the quantity of B minus C is the same as AB minus AC. The symmetric property of equality allows the distributive property to be written as follows. So again, this is just a generic form, rewriting what I had stated above. Evaluate each expression using the distributive property. Here we have 3 times the quantity of 2 plus 5. So what we need to do here is we need to take this 3 on the outside and we need to distribute it to everything on the inside. So really what we're saying is 3 times 2 plus 3 times 5. 3 times 2 is 6 plus 3 times 5, which is 15. Add them together, and we get a result of 21. Let's take a look at letter B. Here we have the 4 that's on the outside is on the right-hand side. You still treat it the same way. Distribute to the 9 first, and then the 7. So it's really 4 times 9 minus 4 times 7. Well, 4 times 9 is 36, minus 4 times 7 is 28. 36 minus 28 is 8. Go ahead and try letter C on your own. Letter D. Julio walks 5 days a week. He walks at a fast rate for 7 minutes and cools down for 2 minutes. Use the distributive property to write and evaluate an expression that determines the total number of minutes Julio walks. So 5 would represent the days of the week. And on the inside, I would put the 7 minutes he runs or walks at a fast rate, and the 2 minutes he cools down. So that right there is our expression. Now let's go ahead and distribute that 5. 5 times 7 plus 5 times 2. 5 times 7 is 35, plus 5 times 2 is 10, and 35 plus 10 is 45. This is a word problem. It deserves a word answer. The question is asking for the number of minutes, so this would be labeled 45 minutes. Letter E. A group of 3 adults, an 11-year-old, and 2 children under 10 years old are going to a baseball game. Write and evaluate an expression to determine the cost of tickets. Use the chart provided. Okay, so we have 3 adults, and the adult cost is $5. And we have an 11-year-old and 2 children under 10. The 11-year-old would fall in this category, children single game 12 and under, and so would the 2 children under 10. So here's how we're going to do this. First, let's take care of our adults. 3 adults times the $5 plus, we've got an 11-year-old, that's 1 child, plus the 2 other children that are under 10, and that price is $3. So let's go ahead and use our order of operations here. We're going to distribute this 3 first to take care of our parentheses. I'm going to bring down the 3 times 5 plus, and let's distribute. We have 3 times 1 plus 3 times 2. Now let's do our multiplication from left to right. 3 times 5 is 15 plus 3 times 1 is 3 plus 3 times 2 is 6. Add those together and we end up with 24. It wanted to know the cost of the tickets, so let's go ahead and throw a $sign as our label. The distributive property can also be used to make mental math easier. Try these few examples below. Letter F. So here's what we can do. Let's say we didn't have a calculator. And we wanted to multiply these numbers. We can definitely take these numbers and multiply 12 times 82 and go through that process. But I want to use mental math, and we can do that by using the distributive property. I can take this 82 and change it to a sum, 80 plus 2, and bring down our 12. Now we can distribute, and I can now do this mentally. So when we distribute 12 times 80, it's really 12 times 8 and add a 0 to the end. So 12 times 8 is 96, and let's go ahead and add a 0. So 960. Now we do 12 times 2, which I know is 24. And I can add this very easily in my head as well. 960 plus 24 is 984. If you were to use a calculator, or if you were to do this multiplication over here, you would get the same answer. However, using the distributive property makes it much more simpler and a little bit quicker to do. Letter G. We have 44 times 2.5. So I'm going to go ahead and break apart that 2.5 into 2 plus 1/2. Oops. Okay. So let's distribute. 44 times 2 is 88. 44 times 1/2. It's really 44 divided by 2. So 44 divided by 2 is 22. And then we add those together and get a result of 110. Go ahead and try letter H on your own. Simplify expressions. An expression is in simplest form when it contains no like terms or parentheses. Rewrite each expression using the distributive property, then simplify. So we're going to do a little bit like what we did on the front of the page. However, now we're putting variables in there. So let's take a look and see what happens. Letter A. 7 times the quantity 3W minus 5. We're still going to distribute that 7. 7 times 3W is 21W. 7 times 5 is 35. But this has a minus sign, so really it's like saying 7 times negative 5, which is negative 35, meaning my final answer is 21W minus 35. Letter B. Here we have a trinomial inside the parentheses, but it still works the same way. We have 4 on the outside, and we're going to distribute it. 4 times y squared is 4y squared. 4 times 8y is 32y. And 4 times, remember, negative 2 is negative 8. So we have 4y squared plus 32y minus 8. Go ahead and try letters C through F on your own. Like terms are terms that contain the same variable, with corresponding variables having the same power. Only like terms can be added to or subtracted from each other. So here we have 5x squared plus 2x minus 4. There are 3 terms, 5x squared, 2x, and negative 4. None of them are considered like terms. You have to take a look at the variables. So I have x squared in the first term, x in the second term, and no variable in the third term. Because the variables are not identical, there are no like terms. However, in this other example, we have 6a squared plus a squared plus 2a. If you notice, these first 2 terms both have a squared. Because they both have a squared, they can be combined. The way we do that, remember a squared has a 1 in front of it, a coefficient of 1. So it's really taking 6a squareds plus 1a squared, which would equal 7a squared. So let's do some examples below. Simplify each expression. If not possible, write simplified. 17u plus 25u. So let's take a look at the variables. The first term has a u. The second term has a u, both raised to the first power. Therefore, they are like terms. So all I need to do is add those coefficients together. 17 plus 25 is 42, so I have 42u. Letter H, 5 minus y plus 17. Now I have a term in the middle here that's y, and I have no other terms that have y's. However, I have no variable with the 5 and no variable with the positive 17. Those are constants. I can combine those. 5 plus 17 is 22. I can't do anything with this middle term, so I'm simply going to bring it down. So h simplifies to 22 minus y. Letter I, 6q squared plus 3q minus 1. So my first term has a q squared, the second term has a q, and the third term has no q. So there are no like terms, which means it cannot be simplified any further. So we'll write simplified. Try the last three on your own.